So I'll be talking about the routing security. So this talk will briefly cover how secure or insecure the internet is at this point of time. And this perfectly fits David's talk, as a lot of people always say, DNS plus BGP is the internet. So we covered DNS in quite a bit of details, including the root part. Next we go with the BGP side of things, how BGP scales with respect to the routing security. So quick fundamentals of the global routing before I proceed with respect to the route filtering. Well, internet, as we all know, is network of networks. So internet is stitched together by various networks, all speaking border gateway protocol. This is what is the common protocol at this point of time, which is used across networks. So a network may be running a different protocol inside, but to interconnect with any network outside of its boundary, they use BGP. Then you have around 65,000 autonomous systems which are stitching it together, and these 65,000 ASNs are the ones in case of IPv4, while somewhere around 17,000 in case of v6, because still a lot of AS numbers are not dual stacked. What connects these 65,000 ASNs together is somewhere roughly a list of 15 autonomous networks, which, and I hate to use this term, called transit-free or the tier 1 network, because this term is quite heavily abused by marketing folks. I'll go in the technical detail of the tier 1 network, which is essentially a network which is running, which is having no transit at all, which just maintains peering relationship and has access to entire routing table, either through its customers or through customers of its peers. That's what you will call as a transit-free zone. So these 15 networks are the one which connect these networks together. And before we get excited about who these 15 networks are, it's important to know that a large part of the traffic flows outside of these networks, because over the time internet has become more consolidated. So you have more and more traffic going from CDNs towards the eyeball networks, which is not actually hitting the so-called transit-free zone. So still there is an important role which transit-free zone plays in ensuring that you have connectivity across the world. That is how you can guarantee to your customers, or that is how you are guaranteed from your provider that you can reach any part of the internet through these peering and transit relationships. Just an example, so you have, just in the diagram you have AS1, 2, and 3. They may speak any protocol inside, while with each other they will just speak eBGP. So that's fundamentally how the BGP is like. Another example I often use to explain BGP is the case. Let's imagine there's a blackout in this hall, and you want to map who is sitting where. The most efficient way to map that thing is that we pass a paper. We just pass a paper to Arnold sitting in this corner. He writes his name and he writes who is sitting next to him, and you just float the paper around. Within a minute, everyone writes who they are and who is next to them. And within a minute, you would have a table of who is sitting where. That's very efficient, right? Instead of a single authority asking who sits where, it makes much more sense. But this works as long as no one fakes who they are, right? And this is where the problem comes. So I can actually skip this slide, which is about the root DNS servers, since it's quite heavily covered. So besides BGP, DNS plays the role in stitching the internet together. So this brings me to the next part, how trust right now in the BGP works. This is with respect to the fundamental elements on how trust is working. And once we go with the fundamental elements, we can discuss how it works at the internet scale. So take case of filtering. So you have option in BGP where you can filter other networks based on their AS numbers or prefixes or AS path. So based on various other factors, you can decide those filters. So that way you do have the options within the protocol to do filtering. Filtering often works well as soon as you do it close to the edge. Once you move beyond the edge network towards the core, it becomes harder. And I'll get to that problem in the next slide on why it becomes harder. Take this example. You have here AS1, which is provider to AS2. So red is the provider to blue. And now blue says, I have just one prefix. This is my /24. Please announce it. So here, if AS1, which is red, is filtering blue, they can just maintain a filter. It's quite simple, right? Works because they know the customer directly. It's a short AS path. They can easily go and interact with the customer, and it works. What happens when blue adds a customer, which is AS3, green? Now, green will tell blue that I want to announce this prefix. Blue has to tell this to red. as you can imagine, this becomes a problem as the internet grows. So how much of a problem that can be? Well, as per Mr. Jeff Houston's talk a while back and his analysis, average AS path length on the internet is around 5.7. So you can expect to see other network around 5.7 ASNs away from you, which is very hard. How would you know what to accept, what not to accept? You may know while sitting in Delhi what to expect from a network in Delhi. You may not know what to expect from a network in Nairobi or even from a network in California, which becomes very hard. So this brings us to the part on how to scale up the route filtering, how right now it's working at the internet scale with the average AS path length of as high as 5.7, which brings us to the point of IRR, which is Internet Routing Registries. So Internet Routing Registries, these are essentially coming from the starting of internet days. These are just the public registers where you would write something and then you do it. So the concept is I write something what I want to do and then I do it instead of doing it on my own. And it uses something called RPSL, which is Routing Policy Specific Language. So you create route objects here in case of IRR. You define the route object, you define the origin ASN, and you make it work. Now, anyone who is peered with you or who is your customer or who is your upstream, they can go and validate what you are doing, whether it matches what you have registered in IRR or not. So besides the route object, you also have option of AS sets, which as the name defines is a set of ASNs. So in our example, go back to the older example, here blue may have a AS set, which includes blue itself and the green, saying that this is my collection of ASNs which I'm supposed to announce. So here's an example of route object. I'm just querying one of our prefixes. So here's one of the /17. So you see the route, you see the description, which can be just anything. You see the origin ASN, which you are supposed to define in case of route object, and some other information, including when it was last changed, who's the maintainer, and a very important thing, which is the source. So here the source is RADB. So here's another example. We are querying ACT, AS set, which is one of the large providers here. In case of AS-ACT, you see that it is having these following ASNs as part of its AS set, and the source here is Epic. So how many IRRs are there? Who operates an IRR? Again, it comes to the historic days. As of now, there are almost 25 IRRs, with many of them totally dead or haven't made even a single change in last probably 5-10 years or more. They are there because they were started long back, and what gives them relevance is the network operators when they use them. So a popular IRR is RADB, which is a non-for-profit coming from the Merit, and RADB mirrors all IRRs, including the ones which are run by RIRs like Epic or RIPE, etc. So RADB has over the time become more of authoritative source because it is easier for the network engineers to point their tool towards RADB instead of querying all these IRRs. So that's how these 25 IRRs get importance, because right now RADB is mirroring all these. So there are other IRRs including AltDB, the free one. There are IRRs run by the RIRs. So if you are in this region, you might have your allocation directly or indirectly from Epic. So you may create records at Epic. If you are in American region, you may create your route objects on Erin and so on. RADB is going to filter all these. Now, when you generate filters, it's up to you which one you want to point to. You may define your tool to query all these IRRs separately, or you may define your tool to just query RADB, which is mirroring all these. Here's an example of query to RADB. So here we are querying for one of the prefixes for Bharti Airtel, which is a large ISP here. We just query for this prefix. It shows you the prefix, just a similar format as we saw before, but here it shows the source. The source is Epic. If you query RADB, you will see the route objects registered in Epic, but the vice versa is not true. If you query Epic, you will only see the route objects which are there in Epic. It will not reflect the route objects of RADB or someone else. So this is how RADB became more popular over time. Apart from RADB, it's also known that entity communication running an IRR is also mirroring most of the IRRs. Besides entity, we also have reach. We also have have Bell Canada running the IRR. So we have a system in place. What next? How do you generate filters? So this brings us to the tool called Bgp Q3. This is an open source tool published on GitHub. You can use this tool for generating filters. You can query an IRR, generate the filters. It works very well. You can just query with the AS number or query with the prefix. It will help you in getting the filters. It by default supports Juniper as well as Cisco. Plus it allows you to put your custom format in. So with your custom format, you can use pretty much any hardware you are using. I've used Bgp Q3 all the way from Juniper, Cisco to Brocade, Huawei, Microtech, just whatever I get on, and it works. It also supports JSON output, which is great for programmers in the room. Apart from that, it supports V6 as well as the AS path-based filter. But the last point here is very important, and I cannot stress less on this. It only supports generation of filters. You do need to have a mechanism in place for pushing these filters to your router config, which in itself can be a tedious task for a large network. Here's Bgp Q3 in action. So I've just queried one of the ASN I used for R&D purposes. So I've queried it with L, which is the list name, Anurag, and then my AS number, and -6 because this ASN just uses IPv6, so it's generating the simple IPv6 config. So it shows me all the prefixes which are here registered in the Cisco iOS in the blue, and for Juniper in the red, which I can use to tweak my filters. What it is doing in the backend, it's pretty much just querying the RADB, and you can see it over here. I'm not sure if it would be visible in the backside audience, but we are going to publish the slides, so feel free to download them and see them afterwards. So you're just querying it's whois-h, whois.radb.net, and then a specific syntax, which is exclamatory mark, and then 6 for IPv6, and then the AS number. It just gives you back all the prefixes which are registered with this ASN. And since we are querying RADB, this includes all IRRs which have this prefix in place. So this confirms that we have a system in place, you have possible tools in place. So this brings us to the next question. How well is the IRR filtering? We do have system in place, so why even worry? And the answer to the point is how well it's working. It's terrible. It's not at all well. It's actually bad. So let's get into some statistics on how well route filtering is working at the internet scale right now. So I looked at all the prefixes in the routing table and tried to match them with respect to the IRR, whether they validate or do not validate. And out of something like 7.5 lakh prefixes, or 750K prefixes, only 79.54%, so little less than 80% have a valid route object, or they have a valid route object and that includes in the AS set of the upstream. There are cases where almost like 58,000 prefixes do not have a route object at all. And then this includes almost 12% of the table, which is 96,000 routes with a mismatching route object, where person who wrote in the register, I want to do something, they're doing something totally separate. And that's a problem. So if you start a strict IRR-based filtering, you're going to black hole something like 1.5 lakh routes in the table, which is almost like 20% of the global routing table. And this is the problem which we encountered at Hurricane Electric when we were trying to implement large-scale filtering, because it becomes tedious. You cannot simply black hole these routes. There are a number of false positives here where someone just does not know that they have to maintain their route objects. How are the stats for the Indian networks? Let's have a look. Again, excuse me for using not so good fonts. So I can read this out. So the left one here is Bharti Airtel. So in case of Airtel, it's something around 7.5%, which is mismatching, and then there is a large part which is missing in here. The second one here is SIFI, which is missing something like 1%. In case of Vodafone, again a larger percent. This problem is common, and remember, this problem may not directly belong to these networks. So when we say 7% of the routes are mismatching for Airtel, that may not be directly related to them. That means the routes they are announcing, that may include the route which they originate as well as their downstream routes. And if downstream customers of say Airtel or SIFI or Vodafone are not maintaining their table well, that can reflect in this data. The last one here in the list is Reliance Jio, where I saw only one route having problem and the rest of table being clean. But the fact that they don't sell IP transit is can be one of the reasons, because essentially their table includes only their routes, not a large number of downstream routes which have these problems with the smaller networks. So are these just the statistics, or there is a real world problem here? Do we need to even worry about these statistics, since networks are right now routing these? So you don't have problem in reaching this 20% of the routing table, do you, or not? Actually, you do have a problem. Let's first look at the real world problem. There are a number of route hijacks which have happened. The first one, quite popular case, starting from 2008. It got good popularity, especially after someone posted a video of this scenario from Bgp Play on the YouTube. So government of Pakistan asked PTCL, a large provider there, to block YouTube for some reason. And PTCL added a black hole route for this prefix in their router, which is fine probably for their network, as they had to follow the regulator. But instead of just keeping it to their network, they also started originating that black hole. So they at that time, Google was originating a /23 for YouTube, while PTCL started originating a /24. And there we go, more specific always prefers. So now instead of blocking YouTube just in Pakistan, you had this block affecting a lot of people all the way from Europe as well as to US. A large part of traffic started flowing towards Pakistan. By the time Google realized, they actually started originating a /24 as well, so that the AS path length can take care of things to some extent. So at least the cases where people are directly paired with Google do send them traffic instead of sending it to PTCL. There was another case where it was the Google's route leak by Airtel back in 2015. Actually, it was more of a case of Hathaway here, which leaked the route, and Airtel carried it further, and it went on, and globally it was accepted. So upstreams of Airtel accepted it, and it actually had a significant impact as per the news. There are other cases of targeted attacks on the payment systems, in recent years, where number of cryptocurrency companies are being targeted because of route hijack. And while I wrote these slides, earlier, 2 days ago there was a major problem where one of the customers of Verizon leaked them a large part of the routing table, and Verizon accepted it. And that caused outage for many large networks. That includes Cloudflare, and there were visible impacts on Amazon as well. That was just 48 hours ago. I don't have that in slides, but that's the case. So there is a real problem of route hijacks impacting the internet, and can operators do something about it? Unfortunately, at this point of time, there is no easy way out, because if operators do strict filtering, they're going to cause problem for remaining 20% of the table. Maybe out of that 20%, possibly 18 to 90% are the cases where people just don't know what they're doing, and maybe rest 1% can be route hijacks or route leaks. So why we have this problem at all? The challenges with IRR-based filtering. Well, IRR is old. It comes from the days of starting of internet. It's very hard to integrate, and that's what I mentioned in case of Bgp Q3 example as well. You'll find number of tools like Bgp Q3 which can generate filters, but you need to have a mechanism in place where you can go and update the filters. And it's not a one-off task. If you are connecting a customer, ideally you want a system where you keep on rewriting your config, maybe at least within the next 24 hours, not later than that. So you have to regenerate the filter so that you don't have to deal with your downstream to deal with that. The other problem with respect to IRR is that whatever goes there stays there. And this is interesting because you might have seen, if you have queried IRRs, they might include all the historical route objects which are created. So if a prefix moves from across the providers, people keep on creating new route objects while the old one just stays there. And if you try to create at the same IRR, it may give you an error. But if you do use different IRR, it will just work fine. So in theory and in real, you do have cases where you can have a prefix with a route object registered with, say, AS1 as the originator in Appinix data, while you may have a totally separate thing with AS2 as the originator in case of IRR, in case of say ALTP, and something totally separate in REDB. So that creates a conflict. There's no direct incentive for the smaller networks to maintain their entries. If you are not forced to maintain, why bother? You can just put something what you want, and as soon as your upstream routes it is going to work. But there is incentive. I'll come to that in a second. There is still a good incentive for you to still maintain your IRR entries quite well. And the last part, which is the important part, that software speaking to the routers is still a newer concept. The networking industry is still to take it further. It's quite popular to have large exchanges following it, because it's easy to update an exchange route server, which is essentially a Linux server in most of the cases, instead of updating a router on the regular basis. So the future. There are some interesting developments which have happened. So we implemented the route filtering in our network based on IRR with certain exceptions, of course, because of the 20% problem. There are other examples, including AT&T, which is quite recent. So since November 2018, AT&T implemented RPKI for its peers. So if AT&T learns your routes from its peers, and as long as you have a valid ROA, AT&T is going to keep it. If you have an invalid ROA scenario, they're going to drop it. That creates a big incentive for people to start using RPKI, which is much better technology than IRR, but still not a complete replacement due to its own reasons. RPKI is being pushed quite heavily. In case of exchanges, exchanges are doing much better at this part, and this includes DECIX as well as INNOG and Bharat IX, where I'm volunteering for running the tech platform. It's much easier to implement IRR-based filtering as well as RPKI-based filtering, because here you have softwares generating the config, and essentially to update config, you're just rewriting a config file. It's just a Linux server. You don't need to have a mechanism to push config, and even if you need to have that mechanism, it's much easier with the newer versions of Linux operating system against super old legacy hardware, which would have its own challenges. There are cases in number of vendor implementations where you cannot simply go and rewrite the prefix list. You have to do no prefix list, and a lot of network operators would be scared of doing it, because when you are doing no prefix list and adding a new prefix list, you are causing an outage for a customer, and possibly for over 10 to 15 minutes in the BGP convergence time. So RPKI being pushed quite heavily, it has much more easier implementation. And the next version of IRR, which is IRR version 4, that includes integration of somewhat with RPKI, where it is going to validate with the route object. If that exists, then it's not going to allow you to create a route object against the ROA, which helps to clean up a bit of junk, at least going further. Here's an example of RPKI in action, way more easy to implement at a router scale. So in this example, what we are doing is we are just learning the prefix here. So we say give a lower priority if the RPKI check is invalid. Keep it neutral with a local preference, something like say 100. If there is no ROA present, give it a higher local preference. Prefer this route if ROA check is valid. This is what essentially we need to do over time. If you're a network operator and you're worried of putting RPKI, maybe you can have a lower local preference. Or if you're adventurous enough, just put a drop. As soon as there is a mismatching ROA, just do a drop of the prefix. An easy way to check whether your network or your provider's network or the organizations you work with for the RPKI. So we have a tool, bgp.he.net, which you might have used for looking at the BGP routing tables, that includes checks for the prefixes. So you have green check if there is a valid route object. You have a dark green check if there is a parent route object. So if the origination is happening for 22, you have a route object for 22. It shows you green object. If you have an origination happening for 21, while the route object happens to be for /20, you have a dark green. The red check shows you the case where there's a mismatch. So if you see mismatch with your prefixes or your provider's prefixes, please help in cleaning that up. You have a green key for RPKI check valid, red key when there's an invalidation with respect to RPKI. Here's an example. So with the Cloudflare prefixes, you see green key as well as green check. That confirms that the IRR as well as RPKI implementation is okay for these prefixes. Here's another example, Beam Telecom, some of the prefixes, not all, I cannot put all the prefixes in the slide, but this shows red check, which shows there's a mismatching route object here, and you don't have any key because the prefixes are not signed so they don't have an ROA created, so there's no validation for RPKI. Another example, so Bharti Airtel, some of the prefixes with green, some of the prefixes which feels like probably they started originating over time for some customer which probably did not update their IRR route objects. So you just see a red check. If we do a hard filtering right now, you're going to black hole these routes. So do contribute in the cleanup, and if you see these problems going around, you see your network, with not so clean records, do update them. If you have resources here, contact Apnic through my Apnic portal, update them. If you have resources from IRIN, I'm sure there are members from IRIN over here. You can speak to them about it. You can probably mail them and have it created. If you see your provider, having these problems, please do mail your provider. There is a real effect, because when exchanges filter your routes, you will have a sub-optimized routing. And I have seen this in a number of cases before, where with a good prefix, with a proper IRR, I have a direct route. While with a prefix with IRR problem, I just have an indirect longer path. So that's pretty much about it. I have references in the slides. You can download the slides later if you're interested in any of these topics or any of the tools I mentioned. I have put them over here. That's about it. Any questions? All right, thank you.